On last night's video, you were asked to keep notes on number 1 from the forces classwork handout. What we're going to do today is, on this video, I'm just going to talk a little bit more about forces, and we're going to do the next few examples in the packet. And we'll do more with this on Monday when I'm back in school. Okay, so every time you're working with a forces question, the first thing you're going to do is you're going to draw a parallelogram like we see here. And this side of the parallelogram can always represent force 1. And this side of the parallelogram can always represent force 2. And then what happens is, if you have an object, let's say that starts right here, and it's being pulled in this direction, and it's being pulled by another force in this direction, what's going to happen is the resultant is going to pull you right here in the direction of the diagonal, the parallelogram. So whenever they're talking about a resultant, what they're looking for you to do is they're looking for you to draw a diagonal that comes directly out of these two original forces. Okay, don't draw the diagonal going this way. It has to come directly out of the two original forces, and we call that the resultant. Okay, so if we read number 2, it says the measures of the angles between the resultant and two applied forces are 65 degrees and 42 degrees. So before I go any further, instead of making my parallelogram like this, if it says that the angle between the resultant and two applied forces are 65 and 42, well, you can draw your diagram like this if you want, but since 65 plus 42 adds up to an obtuse angle, I'm going to actually draw my forces like this time. So this side is still representing force 1, and this side is still representing force 2, and our resultant always comes out of those two original forces. Now, if we put the 65 here and the 42 here, this looks a little bit more realistic this time. Okay, now as we go back to the problem, it says, and the magnitude of the resultant is 24 pounds. Now keep in mind your resultant is always the diagonal. So this is your resultant right here. So they're telling us that that is 24 pounds. So I'm going to put a 24 right on that. Okay, now, when you're working with forces, you really just have to look at one of the triangles. You don't have to look at both. So let's look at this bottom triangle. I always just pick out the bottom one. They're the same exact triangle. Okay, now, what we know of this triangle is we know that this side is 24, and we know this angle is 42. Now, this 65 is not within our blue triangle, but if you keep in mind, this angle and this angle right here are alternate interior angles, so they have to be congruent. So that tells us that this one over here is also 65 degrees. Okay, now the question says, find to the nearest pound the magnitude of the larger force. Okay, so we have two forces, force 1 and force 2. Now, the larger force is going to be across from the larger angle. So if we look at force 2 right here, that's across from an angle of 65 degrees. Force 1, even though we see it over here in our parallelogram, if we were to look at this in the blue triangle, force 1, this side of our parallelogram, is equivalent to this side of our parallelogram. So this side is across from a 42-degree angle. So since this side is across from a smaller angle, force 2 is going to be the bigger force. It's going to be the larger force because it's across from the larger angle. So since we're looking for force 2, you could call that A, B, you can call it whatever you want. I'm actually going to call it X. So I'm going to put an X on this side of the triangle. Now what's nice about this triangle is that we know that if this is 42, this angle right here, and if this angle is 65, well, there's 180 degrees in a triangle. So if we add up 65 plus 42, that gives you 107, and subtract that from 180, we actually found this angle right here as well. All right, so now in order to find side x, we have to say, are we going to use law of sines or are we going to use law of cosines? And keep in mind, law of cosines we use when we're working with 3 sides. Law of sines we use when we're working with 2 sides. Now, we know this side of our blue triangle, and we're looking for this side, so we're really only using 2 sides. So for this, we know we're going to use law of sines. if you want to write it out, A over sine of A equals B over sine of B, you can do that. Now you don't have to label your sides A, B, and C, but if it helps you, I mean, you totally can. So A and B, lowercase a and b, represent the two sides we know. So let's just call this x side A, so that would make the angle across from it angle A. If we're calling this side B, then angle B would be over here across from it. And we'll just make this C. So now when we plug in our numbers, we're going to have A over sine of A, so x over sine of 65, equals B over sine of B, so equals 24 over sine of the angle across from it. And now you could just go through and just cross multiply. So x times, so x times sine of 73, you could just write as x times sine of 73. And 24 times sine of 65 would be 24 times sine of 65. And to get the x by itself, just divide both sides by sine of 73. All right, so all you have to do is just plug this entire thing right here into your calculator. And the question says, find to the nearest pound. So that's telling us that we have to round to the nearest whole number. So when you plug this in your calculator to the nearest whole number, you will get 23 pounds. And be sure to label your units, okay? Be sure to write the word pounds right here. Now, I know some of these problems can be a little tricky, so if you want to stop the video at this point and, rewind it or try the problem on your own just to make sure you get the gist of it, that might be a good idea. Okay, so now we're going to skip ahead in our packet to, we're actually going to jump all the way to number 7. So if you guys take a look at number 7, it says two forces of 40 pounds and 20 pounds, respectively, act simultaneously on an object. All right, so let's first draw that out. We know when we're dealing with forces, we're first just going to draw a parallelogram, and we said the resultant is the diagonal right down the middle. And it says our forces are 40 pounds. This one looks bigger, so I'll make this one 40. And 20 pounds. I'll make this one 20. Keep in mind, here are our two original forces, okay? When we draw these, just to be consistent, I would always make the left side of the parallelogram and the base of the parallelogram force 1 and force 2. And the resultant every time is the diagonal that comes out of those two forces. Okay, so now as we keep reading, it says the angle between the two forces is 40 degrees. So it tells us that this whole entire angle, this whole thing, is 40 degrees. Now it doesn't mean that we're going to be cutting, this up into 20 and 20. The only way these angles are going to be the same is if these two sides are the same. If these two sides are different, I mean, you could tell just by looking, this angle looks a lot bigger than this angle. Okay, now what the question asks us to do, there's two parts. It first wants us to find the magnitude of the resultant to the nearest tenth of a pound. Now, magnitude just means the length, so we're looking for the length of this resultant. So since this is what we're looking for, I'm just going to put an X on it. Okay, and again, I like to work with just one triangle at a time, so I'm going to just outline this bottom triangle right here to show this is the triangle we're working with. And let's just label everything we know onto that triangle. Okay, well, since this side is 40, so is the top, but that's not in the triangle we're working with, so I'm not even going to bother putting that there. I mean, you can if you want. If this side is 20, the side across from it would also be 20, and we do need that because that's in the triangle we're working with. Now, even though this 40-degree angle right here doesn't help us with these two individual angles, what it does help us with is it helps us find this angle, because when you're working with a parallelogram, these two base angles here, these two angles on the bottom, have to add up to 180 degrees. So if I did 180 minus 40, it'll give me this angle right here. So 180 minus 40 is 140. Okay, so this is pretty much what we have about the triangle. We know two sides, and we're trying to find a third side, and we know one angle. So when you're working with 1, 2, 3 sides and an angle, we know there we're going to have to use law of cosines. Okay, so I'm just going to call this part A. And since I labeled the side we're looking for as an x, I'm just going to write law of cosines as x squared. And that's going to be equal to the sum of the squares of the other two sides, so 20 squared plus 40 squared, minus 2 times the product of the other two sides, so 2 times 20 times 40, times cosine of the angle that's across from the side we're looking for, so cosine of 140. Okay, so you guys can just, whenever you're looking for a side, you can just plug this entire thing in your calculator just like you see it. And when you do, you end up getting 3,225. I like to round to at least 4 decimal places, so 0.6711. And then to get x by itself, we just take the square root. So we get x equals, when you take the square root of that, they want you to round your answer to the nearest tenth, so it'll be 56.8 pounds. Okay, now this question also has a part B. I mean, they don't label it part B, but it does have a second part. It says, find the measure of the angle to the nearest degree between the resultant and the larger force. So since this is our resultant and this is our larger force, we're looking for this angle in here. Okay? So, I mean, you could call that whatever you want. If you want to label the triangle A, B, C, you can. You don't have to. But I'm going to say we're looking for angle A. Now, here, you have to decide whether you're going to be using law of sines or law of cosines. I mean, technically, you could really use either one you want, because if you wanted to use law of cosines, we do know the 3 sides, so we can find an angle. If you want to use law of sines, we could be, we know all the sides, and we're working with 2 angles. So you can use either one. I usually find law of sines a little, shorter when you're looking for an angle, so I'm going to use law of sines. I'm going to say A over sine of A equals this side that we just found right here over sine of the angle across from it. So C over sine of C. All right, I'm going to do that up here. So part B, we're going to do A over sine of A equals C over sine of C. Okay, so now you can just cross multiply. So when you cross multiply, I guess we should plug in the numbers first, huh? Okay, so when you plug in the numbers, we're going to have 20 over sine of A, because A is the angle we're looking for, equals 56.8 over sine of the angle across from it, so sine of 140. And then just cross multiply. So when you cross multiply, you get 56.8 times sine of A equals 20 times sine of 140. And to get the sine of A by itself, you divide both sides by 56.8, leaving you with sine of A. You can either leave it as this fraction that you see right here, or, I mean, if you want to plug that into your calculator and write it as a decimal, you can write that as 0.2263. But whenever we don't know an angle, we have to do sine inverse of that decimal. So if we want to find the measure of angle A, we're going to have to plug in our calculator sine inverse of 0.2263. And when you do, to the nearest degree they want it, you get 13 degrees. Okay, what I'd like you to do now is try number 8 on your own in the packet. And when you're done, you can watch the second part of the Forces Classwork video. That'll be on Google Classroom, and see how you did.